Welcome back to Discovering Geometry with Mrs. Berry. We are on lesson 11 now. Today we will be finding the nth term. We're going to look at patterns, we're going to notice constant differences, and then we're going to be able to come up with rules to help us analyze these patterns. Sequences are a series of numbers. When we look at a sequence such as 20, 27, 34, 41, 48, we can use our inductive reasoning to find the pattern, and then we can use that pattern to find the next few terms. So what do we see here in this pattern? From 20 to 27, we see an addition of 7. From 27 to 34, we see another addition of 7. 34 to 41, there's another 7. And of course, this one's a 7. So how would we find the next few terms? We would add 7 and we would get 56. We would add 7 and we would get 63, and so on. So we can keep going and we can definitely find the next few terms. But what if somebody asked us to find the 100th term? Would you want to write all the terms in between? Do you think maybe there's an easier way? Of course there is. We're going to come up with a function rule. So let's look at what that means again. Here's our same sequence. There is a better way. If we could find a rule that would give us any term, then we could calculate any term, including the 100th term. So when we find this rule, we're going to use n to represent the term number. As in, this is the first one, this is the second one, this is the third term, the fourth term, the fifth term. So n is going to represent these term numbers. So in the example above, in this one that we have right here, n is 3 for the number 34. So let's see if we can figure out a way to find the rule. So here we're going to play with the rules. We are going to make a table and the rule is already listed. We're going to fill out the table and we're going to see if we can figure out a pattern where we know what the difference is between the consecutive terms and where that plays into the rule. So here we go. We have n is just the number of terms, remember, so we're always going to count up from 1. And then our pattern here is 3, and then 4, and then 5, and then 6. What's going to come next? 7, and then 8. I have to change my colors so that we can see what I'm writing on that white. Let's see if this works a little bit better. So our next number is going to be 7, and then our 6th term will be 8. Okay, so we're counting up. This difference right here is plus 1. This is plus 1, plus 1. All right, so we're going to have to figure out where that plus 1 comes into this rule. Let's do another one and see how we can figure it out. Okay, so again, our n's are at the top. That's just our term number, so we're just counting up there. But our pattern, our sequence starts with -1, and then it goes to +1, and then +3. So it looks to me like we're adding +2. So from 3 plus 2 would be 5, and then 7, and then 9. So we're adding +1. Our rule was n plus 2. If we're adding +2, our rule is 2n minus 3. All right, let's do some more and see if we can figure out where our constant difference comes in. Okay, here we have -3n plus 7. I'm going to go from 4 to 1 to -2. Okay, so 4 to 1, I'm subtracting 3. 1 to -2, I'm subtracting 3. So -2, if I subtract 3 would be -5. If I subtract 3 more, I'm at -8. 3 more, -11. So here I'm subtracting 3, and my rule was -3n plus 7. Okay, one more. Hopefully you're starting to see where it comes in. All right, my first term is -3. My second term is 2. My third term is 7. I don't like negative numbers. I'm going to do this difference first. Between 2 and 7, I added 5. So from -3, if I add 5, I sure do get 2. All right, so I'm going to add 5 and get 12, add 5 again and get 17, add 5 again and get 22. And my rule was 5n minus 8. Are you seeing where the constant difference comes in to the rule? Our plus 2 was the 2n. Our plus 1, there was a 1 in front of here, right? -3, -3. So how do we find the rule? So we now know that we were seeing that constant difference in front of our n. Now we're going to have to figure out what the rule is. Where do we get that something? So here's a new sequence. We have 4, 1, -2, and -5. Okay, our constant difference here, we're taking away 3. Now we're taking away 3. We're taking away 3. If we take away 3, we'll get -8. If we take away 3, we'll get -11. Okay, so we know that the constant difference is -3. So we know that our rule is going to start with -3n plus something or and something. And now we're going to kind of work backwards. We're going to put a C in for that something. So I'm going to start with my rule as -3n. I know it's -3 because that's my constant difference. That's what I'm going down by in this case. And then my term number is n, that we need that in the rule. And then I have something else. I know that I'm going to do something else. So to solve for that something else right here, I'm just going to pick one of these and put in the n and then say that that's equal to whatever that number is. So in other words, I'm going to put -3n plus c is equal to the sequence. So whatever I pick, if I pick the first one, then I'll put n as 1 and the sequence would be 4. So generally we do just use the first one, though I could point out we can use any of them. We could put 3n for n and the sequence as -2. Okay, generally we pick the first one. So I'm going to say -3 times 1, because see, that makes that multiplication really easy if we pick the first one. Plus c, c is what I don't know, and what I'm trying to figure out is equal to, since I use this one right here, I'm going to say that it's equal to 4. Now I just need to solve for c. Hopefully you remember your algebra, and that's pretty simple. So -3 plus c is equal to 4. If I want c by itself, I'm going to do the opposite of -3. I'm going to add 3 so that over here I get 0. If I add 3 over here, I'm going to get 7. So c is equal to 7. So my rule for this one is -3n, and I had plus c, and c is 7, so plus 7. So that's my rule right here, -3n plus 7. Now that I have the rule, I can find any term. If you want to find the 100th term in the sequence, we'll just substitute 100 for n in our rule. So our rule was -3n plus 7. So if I substitute n as 100, what am I going to get to? I have -300 plus 7. So that will be equal to -293. So that's my 100th term. Now, how can we use this in a word problem? Is this going to be tough? Let's see. If you place 200 points on a line, into how many non-overlapping rays and segments does that divide the line? All right, before you go drawing a really long line and putting 200 points on it, let's start a little smaller. So let's make a chart of how we could do this, starting with 1 point and then 2 points and then 3 points. Let's see where we get. So if I draw a line and I put 1 point on it, how many non-overlapping rays and segments does it divide the line? Well, I have this ray and I have this ray. Anything else would overlap, and there's no line segment. So non-overlapping rays, I have 2, and non-overlapping segments, I have 0. So my total rays and segments would be 2. Let's draw a line with 2 points. How many rays and segments do I have now? Well, I have 1 ray on this side and 1 ray on this side. And they're not going to overlap. And then I have a line segment in the middle. So I have 2 non-overlapping rays and I have 1 line segment in the middle. Total would be 3. All right, how about 3 points on the line? I still have 2 rays. And now I have 2 line segments in the middle. So my total is 4. Hopefully you're starting to see a pattern, but let's do one more. What if I put 4 points on the line? Well, every time we just use the rays at the very end. So every time we have 2 rays, every time. And then I have 1, 2, 3 segments in between the 4 dots. So I have 3 in between the 4 dots. I'm going to have 4 in between 5 dots. I'm going to have 5 in between 6 dots. And then I need to add these up. So 5, 2 plus 4 is 6, 2 plus 5 is 7. So what do I think that this is going to be? What is my pattern for n? Well, no matter how many dots, I'm going to have 2 rays. And I have 1 less segment than I have dots. So n minus 1. So what's my total? My total is n minus 1 plus 2. So really that comes down to n minus 1 and plus 2 is going to be plus 1. So if all I'm looking at is the total here, then if I put 200 points on the line, I'll have n for 200, and I'll have 1 more than that. So I'll have 201 non-overlapping rays and segments. So these patterns that we've been doing, these rules that we're generating with this sequence, they have a constant difference. That means the difference between each term was the same. We added 1, or we subtracted 3, or maybe we added 5. That constant difference makes this rule be called a linear function. Because it has a constant difference, it's called a linear function. Now, if you don't understand why they are called linear, let's graph a couple of terms as our x and our value as our y, and let's see why they are called linear functions. So from our last example, we had 1 point on the line, we had 2 non-overlapping rays and segments. So this was our term number, and this was our answer, our non-overlapping rays and segments. Here's our term number 2. We had 3 non-overlapping rays and segments, and then with 3 we had 4. So I'm going to graph that, or I'm going to plot these points as XY coordinates. So 1, 2, 2, 3, 3, 4, and what does that look like? Well, it looks like a line. So that's why, with a constant difference, if you were to plot those values, you would get a line. That's why it's called linear. It's a linear function because it forms a line when we plot those points. Next time, we'll study a little bit more and maybe we'll find a rule that isn't a linear function. But today's lesson, they were all linear.